Welcome back to my channel. Today's video has to do with taking care of outliers, specifically taking care of outliers with a technique called Windsorization. Now, Windsorization it's pretty straightforward. All you do is when you find an outlier, instead of deleting it, you basically end up transforming it into the nearest non-outlier variable. And don't worry if this is confusing, it's going to make sense in a minute. Now, as usual, I'll be using the Penguins dataset, the Palmer Penguins dataset, because it's easy to access and it can be used for displaying a myriad of techniques in R. So first things first, let's go up and load the libraries we need. So we need the tidyverse, we need the Palmer Penguins, we need the Penguins dataset from the Palmer Penguins library, or the Palmer Penguins package. And then we need to library a package called DeskTools, which will actually let us Windsorize our data. So if you do not have the DeskTools package installed, go ahead and install that. All right, so first things first, before we can actually Windsorize any outliers, we need to find outliers, right? And a great way to find outliers is actually just to use box plots, because most box plots built in will actually show you outliers whenever you end up plotting your data. So let's go ahead and use ggplot to do this with the Penguins dataset, and the aesthetics will be species and flipper length in millimeters. With this, the geom we'll be using is boxplot, obviously, and I'll be using a width of 0.2 and a classic theme just to make things a little neater. So let's run this. And what do we get? We see that when it comes to the three different species, the Adelie do seem to have an outlier indicated by these little dots here at the upper and lower extremities when it comes to their flipper length. Okay, great. We can go ahead and remove those. But first, just for the sake of comparison, we'll go ahead and make a separate data frame just for the Adelie penguins. We'll call it Penguins Adelie. And to make this, all we'll need to do is use a simple filter function, specifying that we want the data from the Penguins dataset that is only associated with the Adelie species. So let's run that. Okay, that worked great. And just to confirm that we still have those outliers, let's go ahead and run the same box plot as we did before, but this time with our new data frame. So let's run that. Oh, species Adelie not found. Oh, that's right, it's not the species that's changed, it's the penguins that's changed. Adelie, there we go. Okay, let's run this again. Great. Okay, so what do we see? We see that the outliers are still here. Great. All right, so let's go and remove those. So how do you remove those? Well, the first thing you have to do is you have to create a Windsorized variable. So I'll call it flipper length win for Windsorized. And then we have to say that, or use a function called Windsorize from the DeskTools package. And then we have to specify what we're Windsorizing. So we are Windsorizing the Penguins Adelie dataset, and we are specifically Windsorizing the flipper length in millimeters from that dataset. Next, we have to specify what's called a min-val, actually that's null, and a max-val, which we will also set as null. And basically all these do is that you can set lower and upper limits, wherein if this function runs into those limits, it will actually just delete those values. But we're not going to be doing this for this example. We're just interested in Windsorizing our data. And the next thing that we want to do is set the probabilities. So all these do basically is they set well, let me show you. So we'll set these at 0.04 and 0.96. So all this means is that all of your data that is lower than the first 4% and higher than the last 4% for that variable will be Windsorized. And so basically converted into the 96th and 4th percentile, or I guess the 4th and the 96th percentile, whatever that ends up being. Okay. The next thing we want to state is that na.rm is equal to true. And this just means that whenever this function runs into NA data, it's just going to delete it. And finally, we want to set a type. So now we're going to set type 1. There are 9 different types that you can set, and basically they're just different ways to Winzorize your data. For this video, we're not going to worry about that too much. Just know that you can set it to type 1 and your data is going to be fine. Okay, now that we have Winzorized a variable, we have to reintroduce it into the data frame. So to do this, we are going to write penguins addly and flipper length in millimeters, because that is the variable we are Winzorizing. And we're just going to say that we're just going to bring in flipper length win. And so let's run this. Okay, great. So now we should have this flipper length in millimeters here should have been Winzorized successfully. How do we verify this? Well, we can replot our data. We can replot the box plot we've done earlier. So let's rerun the same box plot on the same data that has now been Winzorized and see if we still see the outliers. So let's run this, and what do we see? No outliers. There are no little dots at the bottom here, no dots at the top here. The data has successfully been Winzorized. The outliers have been transformed into the nearest non-outlier values. Great, there we have it. And that is how you Winzorize data in R. I hope you enjoyed the video.